Hey, thanks. Hey, everyone. Welcome back. Good afternoon. We're super excited to talk to you today about how we're democratizing data science at Uber. My name is Atul Gupte, and I'm a product manager on Uber's data science workbench. My team builds a platform that allows everyone at Uber to explore data science techniques and infuse the power of data into everything that their team does. Over to you, Milene.
Thank you. And my name is Milene Darnis, and I am the product manager of the experimentation platform at Uber. We build a tool that empowers employees to run and analyze experiments. And before we get into the heart of the subject of democratizing data science, we would like to give you some background about the scale and the landscape of the data tools at Uber. So our mission is quite ambitious. It is to ignite opportunity by setting the world in motion. But in order to do that, we have an ally. We have access to a lot of data. Actually, data informs almost every decision in the company. At Uber, we're proud to have been data-driven since the very early days. So we look at things such as trip details, interactions with support, how our promotions are working, basically everything. And all of this data informs our business in many different ways. And we will be giving you some examples of that later in this presentation. And it doesn't even stop there. In addition to empowering Uber employees make better decisions with data, we also empower people outside of Uber, such as cities, make better decisions with data. So this is a screenshot taken from our Uber Movement website. It's a recent initiative that was launched that aimed at sharing some of the Uber data, such as traffic patterns, with cities in order to improve city planning. Awesome. But really, how big is our big data? So I hope the numbers will show in large enough fonts so you'll be very impressed. So every day, more than 15 million Uber trips happen on our platforms, and they're all powered by our machine learning algorithms. More than 2 trillion messages are processed on a daily basis via Kafka, our main messaging system. And our users collectively write more than 1 million queries across Hive, Presto, and Vertica, which are our main analytical data stores. And all of this data represents, on a daily basis, more than 150 terabytes of data that's ingested into HDFS. And if we don't look at daily numbers anymore, but at the total numbers, that represents more than 100 petabytes of analytical data that we store and that we have access to. But without the right tools and the right techniques in place, this data could very well be useless. So now a tool is going to tell you which tools people have access to and how they fit our unique ecosystem.
Thanks, Milene, for walking us through the scale and size of the challenge that we're solving with data. Honestly, what makes this even more unique and exciting is the kind of use cases that our data platform needs to build for. There are a few different pillars that make this challenging. First is our business itself. As you may know, we're a global transportation platform, and we're moving not just people, but also food and packages in cars, trucks, bikes, maybe even planes. Fundamentally, this is a very delicate marketplace with intricate network effects. So all of our tools need to allow our users to actually understand these effects, while also allowing them to seamlessly add new modes of transportation into this marketplace. As you can then imagine, the analytics that this platform powers are also fairly unique. They happen in the real world, and changes happen in real time. In fact, the sheer scale of all of these changes is immense. We've completed over 10 billion trips across 600 cities in 65 countries. Every one of these interactions in space and time is pretty special. So our teams need to be able to understand exactly what happens so that we can make the platform better. And then finally, it's the customers. Our customers are fairly unique as well. We have over 6,000 users across data science, engineering, operations managers, data analysts, and as Milene mentioned, even external parties like city governance officials who depend on us and depend on this data to make decisions. This means that our platform needs to be able to evolve and adapt to these changes while allowing everyone to seamlessly work better together. I now wanted to talk to you a little bit about the people who rely on us. I think that will make it much clearer as we go down this journey of what this data platform looks like and why we built it in a particular way. I mentioned that we had over 6,000 users, but actually, there are some fairly distinct personas that exist in this user base. I'm going to walk you through those, ordered in, in range of their technical skills. And I believe that these personas are fairly representative in any other data science, data-driven organization out there. So first up, we have Reliant Rebecca. On the technical skills side, she has limited skills on the SQL side and is fairly familiar with spreadsheets. Now, she is required to take action based on business insights, but she may not necessarily have the skills or the time to pull raw data and derive insights. In this role, you can expect to see marketing managers, entry-level analysts, or even product managers like myself. Next, we have monitoring Matt. He has a deep familiarity around a small set of metrics. He monitors these, investigates these every day, and takes decisions based on what he sees. In this case, you can see perhaps city operations managers or regional managers who run different Uber cities and regions fall into this persona. Again, they have advanced SQL skills and are fairly familiar with spreadsheets and dashboarding tools. A little more technical now, and we have analyst Anna. She actually assists with a lot of the heavy lifting and is responsible for ad hoc analysis, experimentation analysis, building reports, customizing dashboards for everyone else at Uber. In this role, she does have some limited programming skills as well, so like Python and R, and the typical roles associated here would be data analysts or product analysts. And finally, the most technical person on our platform is Inventor Ivan. He brings to the table advanced SQL skills, is very familiar with Scala and Spark, or writing code in Python and R, does some data modeling, maybe some experimental machine learning as well. And as you can expect in this role, you would expect to find data scientists, engineers, ML and AI researchers. So all of these people work together at Uber, and they need to have access to our data platform to do the various things that they need to do. So let's take a quick look at what this data platform would look like. There are various different layers, all of which are serving the needs of one or all of these personas. So I'm going to walk you through this just a little bit. At the very bottom, we have our data sources. So Milan mentioned Kafka streams, but we also have a lot of other data coming in, things like weather data, trip data, traffic information. All of this lies in our storage infrastructure, where honestly, it's not very useful. So for this, we have our ETL frameworks and data integrity systems to actually transform this data into model tables or custom data sets to make it much more useful to other parts of the business. On top of this rests the more interesting part of our platform, the data exploration tools, the query engines, the knowledge bases, all of which help to mine business insights from this data. We also have the experimentation platform that Milan will be talking about, as well as the data science and machine learning tools that we have. And at the very top, to serve the needs of Rebecca, we have dashboarding, alerting, and monitoring systems that allow these people to consume business insights and make sense of what they're seeing. With that, I'll hand it over to Milene to take you through the rest of the journey.
So you now have a better understanding of the data landscape at Uber. But what makes us think that data is indeed being democratized? That it's not just the Ivans of this world that have access to data science, but also the Rebeccas and the Matt and the Annas. So in order to do that, I would like us to first start with the definition of data science. And I went no further than Wikipedia to find one. It says that data science is a concept to unify statistics, data analysis, machine learning, and their related methods in order to understand and analyze actual phenomena with data. Great. So democratizing data science would mean that instead of one category of users, the data scientists, having access to the right tools to do that, more people in the organization have access to the correct tools to understand and analyze actual phenomena with data. And speaking of tools, this definition talks about statistics. And if I were to find an analogy with a tool, I would think of something more like a hammer. It does one thing, but it does it really well. We could look at statistics as a set of proven methods that we know can answer specific questions. But the definition also talks about data analysis. And here, if I were to find an analogy, I would think more of something like a Swiss Army knife, something much more versatile. It can do many things, because when I think of data analysis, I think about exploring the data, looking for insights, finding patterns, but you don't really know in advance what you're going to find. And because we prefer to tell you stories and use cases rather than just concepts and theories, we will be telling you about how we witnessed and we empowered non-data scientists to do statistics and data analysis at Uber. And I'll start through the example of statistics via experimentation. I actually think that experimentation is a great example for that. Because for those of you who experiment in your companies, you know that it's not just data scientists that are involved in the experimentation process. It's many more people, the product managers, the engineers, the operations people, and all of these people have something in common. They want to be able to analyze experimentation results and understand what they mean. So some quick background on experimentation at Uber. We experiment a lot. We run thousands of experiments every year. And we also experiment pretty much everywhere. Of course, we experiment on mobile. We're a mobile-first company, so we have many experiments running on our rider, driver, eater apps. But something that people might not always realize is that we also experiment a lot on backend, like our dispatch algorithm, or here, the tool that we use to send communications to riders and drivers. And although we sometimes use more advanced techniques than just A/B testing where needed, here I'll just cover A/B testing. And for those of you who don't know, the principle is pretty straightforward. You split a population into two groups, and in one group will see one variation of a feature, the control, and another group will see another variation, which we could call treatment. And the goal of the A/B test is to figure out which variation is the best based on a set of metrics that you have predefined in your hypothesis. And for most data scientists, being able to analyze such an A/B test is kind of standard. It's part of the basic skill set that data scientists are expected to master. And that skill set includes things such as p-values, statistical significance, understanding power, what are the common pitfalls of running experiments. But what about non-data scientists? What about other users? They might be asking questions such as, is the p-value a probability? Or what is sample size? Can I look at the results before I reach this so-called sample size? And those are all very valid questions to ask. Actually, they're not that trivial to answer. So in most companies, what happens is that these people, the non-data scientists, will rely on data scientists to answer their experimentation questions. And that might be fine if you have a lot of data scientists in your company, or if you don't run that many experiments. But I'm guessing that's not the case for a lot of you, and it definitely wasn't the case at Uber. So slowly, data science kind of became the bottleneck in the experimentation process. And it would go like that. A team has the idea of an experiment. The great thing is that this idea can come from everyone. That's kind of the beauty of experimentation. So they put together an experiment plan, and they run the experiment, maybe for 2, 3, 4 weeks. But at this point, they will have generated a lot of data coming from the experiment, but they might not know how to analyze it. And so they have to rely on a data scientist to do it, but because we run many, many experiments and we don't have as many data scientists are typically responsible for more than one experiment at a time. They might be working on up to 10 parallel experiments at any given point of time. So here, the step 3 of analyzing the experiment is actually delayed because you have to wait on the data scientist to be available to do this. And it's only then that the team can conclude on the experiment and maybe launch a new product or iterate on a feature. So here, as you can see, data science being the bottleneck was really slowing the pace of innovation at Uber. So we had to find something. We had to build a tool that would empower non-data scientists to look at experimentation results very accurately. So how did we do that? Kind of counterintuitively, we first built it for data scientists. So bear with me here. I know this is not what you came for. But we knew it was really important to get the data science right. Because if it was right only even at 90% of the cases, we knew that people wouldn't rely on the tool and would still go back to the data scientists to get the answers of their questions. So we wanted to get the data science right. And we had a great argument to do that and to partner with data scientists, because we would tell them, hey, we're going to automate your jobs. No more time spent pulling the data, cleaning it, running the same tests over and over again. We're going to do all of that for you, and you'll have more time to do more interesting stuff, such as machine learning, because everyone wants to do machine learning, right? And so we really had a great argument to help them. And also what this meant for us is that quickly the data scientists became the ambassadors of our product within the organization. So they were the ones actually convincing non-data scientists, their PMs, their operations people in their teams to use this product. And by partnering with data scientists, we realized that there were a lot of nuances that we needed to account for. It was not just the simple A/B testing that we needed to solve. And so one of these nuances is what I'm going to tell you here. It's called pre-existing bias. So when you run an experiment, you expect your two populations to be behaving the same before your experiment starts, so that if there's a difference in behavior after the experiment, you can attribute it to this experiment. So for instance, if we're launching an experiment to increase the earnings per driver, you would expect something like that. So here in the control group, the drivers earn around 10 bitcoins per hour, and in the treatment group, 9.8 bitcoins per hour. And so the numbers are not exactly the same, but this difference is not statistically significant. But what happens when this happens? Here, before the experiment even started, the treatment group was already earning more than the control group. And in this case, it's going to be really hard to analyze the results of your experiment. And you basically have two options. Either you say, I'm going to invalidate this experiment and run a new one, but of course that's a waste of experimentation cycle, a waste of time for your teams. Or you can apply some more advanced techniques to account for this bias and still exploit the data coming from your experiment. And when we talked to data scientists, we realized that a lot of them knew about those techniques, but because they were so busy analyzing so many experiments at the time, very often they didn't have time to apply those techniques. So here, not only did we have the opportunity to democratize the basics behind experimentation, we also democratized for everyone some of those most advanced techniques, like this one. And with all that, and we actually continue to iterate a lot with data scientists, we built what I think is one of the best statistical engine for experimentation analysis. It's quite complex, so I won't go over all the details here, but we have a great article on our engineering blog if you're interested in knowing the specifics. So this is all great. We built a complex framework, we had data scientists that love it, but it's about time we think of our first initial set of users that we wanted to cater to, the non-data scientists, people who don't know those methods and techniques as well as the data scientists. And in order to do that, it was really important for us to make sure that the UI was intuitive enough for people to read the results of experimentation properly. So this is what our experimentation UI looks like. As you can see, it's pretty minimal. We had to blur the metrics, unfortunately. It's pretty minimal, and it only has what's important. It doesn't have too much information. It's not too cluttered. So it really speaks even to less technical people. And some of the things, like significance levels, are clearly labeled. So no need to guess based on the p-value whether something is significant or not. No, we do all that work for you, so people can just read the results. And even things such as pre-existing bias are also very well labeled, so people know that we ran those checks for them, and they can have the peace of mind that this data is correct, this experiment seems to be properly set up, and now I can read the results and rely on the data. And so here we really opened this more advanced statistical methodologies to everyone in the company. But even then, even with an intuitive UI and some of the data science coming from the best data scientists in the company, it was still very important to get documentation and training right. So in the experimentation team, we spend a lot of time writing very clear documentation. For instance, warnings. So the name of our tool is Mentana, and so when people see warnings that they might not understand, they always are linked to a page that will explain what these warnings mean and how to interpret them. We also spend a lot of time educating people around experimentation. For instance, we have a full hour on experimentation at Uber's PM Bootcamp. It's a 2-day training session for new product managers in the company, so that even them, if they're not data scientists, they can understand how experimentation works in the company. And we even have a support channel, so some of the most advanced questions that people might have, or the tricky experiments, they can ask their questions, and they can get an additional pair of eyes with people from our team helping them. So hopefully here I showed you how we democratize something as advanced as statistical analysis for experimentation for non-data scientists. And now we have a lot of users, such as product managers, operations people, who rely on this tool to conclude on experiments without needing the help of a data scientist. And now Atul is going to talk to you about the data analysis part through another example.
Thanks, Milene. Thanks, Milene. So going back to our initial definition of data science, I now want to talk to you about the importance of exploratory data science and the importance of empowering people outside of the data science organization to do more with their data. Now, why is this important? Well, this is what truly allows Uber to accelerate the pace of innovation. By facilitating the contribution of diverse ideas from across the company and empowering these users with the tools to actually explore and operationalize these ideas, we're able to really harness the power of our data without restricting this ability to a small subset of users who are familiar with data science techniques. So while Milene spoke about the need for democratizing access to mature methodologies, what about the new and upcoming use cases, or the techniques that hadn't really become a big deal just yet? So a couple of years ago at Uber, we started thinking about exactly this. In 2016, our data science community was growing pretty rapidly. But teams are experiencing a lot of challenges here. So data scientists are putting together their own hardware, writing their own software, bringing together machines, doing this on their laptops. Getting started was really hard. So if new people joined the team, they would have to do this all over again. If new teams were being spun up in different parts of the company, they would have to reinvent the wheel every single time. This was clearly not a great thing. Now, earlier in this presentation, I spoke to you about the various different, the data platform stack at Uber itself. Well, these data scientists obviously needed access to that, and every single time they would have to write a new connector to all of this data. They would have to figure this out, when new things came on board, if things changed or updated. So accessing these data and services was very complicated. Now, as you can imagine, they were doing all of this themselves. Collaboration was not just difficult, it was fairly impossible. Everyone is using their own software, their hardware didn't talk to each other, the connectors were different. What this meant was the data scientists spent a lot of their time solving for all of these things and didn't have enough time to actually focus on what they were good at. So this meant that while the top 10 use cases, the top 10 product ideas were definitely being looked at, the more exploratory use cases, the things that were not super high impact at that point, they were not operationalized. This meant that data science, again, was the bottleneck, but it was also hampering our ability to provide a best-in-class experience as we expanded rapidly around the world. So it was clear that we needed a unique approach to this solution. And we decided to take a bet here and adopt a two-pronged approach. So one was to improve the productivity of the Ivans, to make the data scientists more productive by giving them access to the tools that they didn't have, the infrastructure that they couldn't find, and the software that they were not writing very well to begin with, to connect to all of these tools and infrastructures. But we also wanted to level the playing field, and we wanted to open up access to the Matts and the Annas, to give them access to this powerful platform, give them the documentation, the tutorials, and the support required to help them get started on their own. Our bet was that if we built our own platform that had all of these users on it together, we would be able to not only own our destiny, but also target Uber-specific use cases like geospatial analysis and connect it to some of our other internal tools like Michelangelo, our machine learning platform. So this was our vision. This was our bet. And we decided to come up with a few core requirements. The first one, obviously, was to make sure that diverse users, data scientists, engineers, operations analysts, they could all work on this platform, on a single platform together. The next pain point that they had expressed was infrastructure. So we wanted to make sure that all of their different infrastructure needs were met through this platform, through stable, reliable hardware that they could trust. Access to data connectors, that was another big problem. So we wanted to make sure that there was a single window that connected to all of Uber's data stores, all of our dashboarding tools, everything that you need to get started and get your work done. And then finally, we had over 6,000 users who depend on us for these things. So we wanted to make sure that whatever solution we had was not only safe and secure and compliant with all of the various regulations globally, but also had an acceptable licensing cost as we scaled and grew. So with that in mind, we decided to build something that we call Data Science Workbench. And we have a very simple mission here, which is to democratize data science by enabling access to reliable infrastructure and advanced tooling in a community-driven learning environment. So let's take a look at what this looks like. We decided to build this as a browser-based tool. This meant that access was limited just to having a browser. It didn't matter what computer you came from. We also standardized around Jupyter for Python and RStudio for R-based work. This allowed us to make sure that we didn't have a proliferation of tools that users were using. Now, each user got his or her own session. This custom session was a compute session that the user could choose what their compute capability was. So data scientists could get access to advanced hardware with multiple cores, large amounts of memory. But the people who were just getting started, the Matts and the Annas, they would get something that was more powerful than their MacBook Air, and that was more than enough to get them unblocked. These sessions came with a bunch of pre-built libraries, so people just getting started could get started with the most commonly used libraries and packages. But if you're a data scientist doing something very specific, you had the ability to modify these, add whatever it is that you wanted to make sure that you were productive. We also made sure that we added a distributed persistent storage to back up these containers. What this meant was that if you're a data scientist, you're fairly familiar with things like Git and version control. But if you're someone just getting started, you don't need to learn this new paradigm and this new tool all over again. So if your browser died or if your compute hardware went down for some reason, the persistent storage would take care of it. The next requirement was a single window connector to all of our systems. So as you can see at the bottom, we have a single window that allows you to connect to all of our various data stores, query engines, dashboarding tools, et cetera. Well, we initially began that as like a convenience thing. We just wanted to make their lives easier. But this summer, when GDPR went into force, this actually paid off real dividends, because now we only had to secure a single channel instead of working with all of the various different ad hoc solutions that teams had come up with. And then finally, our vision was to power complex analytics, which meant that you could do all sorts of interesting things with your data, but you also had the ability to share this with less technical users. So we settled on Python dashboarding with Plotly and Bokeh, and R dashboarding with Shiny. This allowed teams to kind of build these dashboards and share these insights to a broader group. So let's take a quick look at what this UI looks like, right? So it's a very simple browser-based solution with access to RStudio and Jupyter. Now, Jupyter looks exactly like the Jupyter Notebook would on your computer. Same with RStudio. The IDE looks exactly like what you would expect it. And there were two reasons for this. One is that we wanted to make sure the technical users got exactly what they were used to, right? They didn't have to learn something new yet again. And for the less technical users coming on, we made sure that there wasn't some abstraction or layer on top of this. We were giving them access to pretty advanced tools, so they could actually learn these things themselves and use this as they progress in their career. It also meant that we had technical and less technical users working together, so it basically advanced their learning as well. I mentioned dashboarding. This is an example of what those dashboards could look like, right? The ability to share, in this case, I think it's Uber for Business marketing data through rich visualization with people who may not necessarily understand how to use this data or how to analyze it. So this is the bet that we took. It was a pretty good vision. We executed on it. But the only way to judge its success is to see what it actually did in the real world, right? So I'm going to walk you through 3 interesting use cases that used various different aspects of this platform and kind of validated some of the bets that we took when building this. So the first one's going to be about driver partners. The next one is safety, which is a pretty important initiative that our company is embarking on. And then the third one is about Uber Eats, which is our food delivery platform. So let's dive right into it, right? So this one's about driver partners in Europe. driver partners often come to our support agents in Greenlight hubs and complain that they were not getting enough fares per hour, or their driver ratings are low. Both these are pretty critical because it impacts their performance on the platform and their overall satisfaction with Uber. So the teams in Europe, the operations managers, they wanted to find a solution to this. Our support agents, unfortunately, weren't empowered to provide specific actionable feedback. What this meant was that drivers would go in, and they would get generic advice. Obviously, it wasn't very effective. It's almost like going to your doctor and with specific symptoms, and your doctor says, oh yeah, just rest, relax, you'll be fine, right? That's not a great experience, I'm sure. So these operations managers decided to dig deeper into the data. They found patterns, they found these models, and they realized that they needed to actually share this with the support agents. So this is where they turned to DSW. They were already doing their analysis on the platform. They decided to use our dashboards to build out these dashboards where agents could plug in the driver ID and quickly give the driver specific actionable feedback. So this is a quick screenshot of what that looks like. Here, they can actually tell drivers exactly where they should be driving based on their peers, at what times of day could they be driving to improve their earnings. Also looks at the sort of feedback that they're getting from customers to make sure that they can tackle that feedback and address it. Already, we've seen over 71% of driver partners who've interacted with this process have seen their fares per hour go up, and have seen an average ratings increase of 0.15 as well. These are pretty great outcomes for the drivers and in return for Uber as well. The next one's about safety. And this one's pretty interesting because of what the teams are doing. So safety is obviously a top priority for Uber. This example is from Mexico, where this became a pretty big concern for us recently. Mexico has a lot of car theft. Over 90,000 cars were stolen in 2017, and these cars can end up anywhere, including on the Uber platform. So the government recently opened up a database called Repube that allows you to plug in a license plate and determine if a car is stolen or not. But with hundreds of thousands of vehicles on our platform and hundreds more joining every single day, doing this manually was pretty much impossible, right? It's not only time-consuming, but also error-prone. So our teams in Mexico City were trying to figure out what they could do with this. So they settled on using Data Science Workbench to pull in driver documents, run Tesseract for optical character recognition in Jupyter Notebooks, and automate this process of feeding this data into Repube, getting access to it, making sure the vehicle was stolen or not. If it was stolen, it would automatically connect to all of our other data stores, all of our other systems, tag this vehicle, invite the driver to the agent, and verify manually if this vehicle was indeed stolen or not. Now, this was an incredibly manual process. It used to take 3 man-months every single month just at our current scale. And we are growing, growing rapidly. So as new vehicles come to the platform, it becomes even more challenging. But with this solution, they were able to bring it down to under half a second per check. What this meant was we obviously reduced human effort. We made sure that things were not error-prone. And we made sure that we were making our communities safer using technology. And then the final example here is actually one of my favorites. This is from Uber Eats. If you're not familiar with Eats, it's our platform for restaurants and customers to order food from restaurants. So this is from the early days of Uber Eats when we were adding a lot of restaurants to the platform, but restaurant partners were not very happy. They were getting aggregate data from Uber, but they weren't really sure how to use it. They weren't really sure how to make sense of it. And at the same time, they weren't really improving their performance on the platform. So they really weren't sure what to do. This use case is specifically from the Asia-Pacific region. Our teams there were already using Data Science Workbench. As you can see, that's a theme. But they were using it to derive some of these insights, and we were wondering, hey, how do we actually provide these to our agents? So they built out a dashboard with custom support from us, where this dashboard could be shared with external parties. Teams would take these dashboards to restaurants and share hour-by-hour metrics on how things are going on in their restaurant and how they can actually improve it on an hour-by-hour basis as well. So an interesting thing happened after we shared this data. A large restaurant chain in Singapore actually changed their staffing patterns. They realized that they wanted to put their best chefs and their best front of house staff at the time when they were getting the most valuable orders, and that improved their performance on the platform, improved their ratings, improved their retention rate. So it was a win all around. What this meant was obviously restaurant satisfaction went up, and some of the vanity metrics that we were capturing earlier were removed because these teams proved that the right metrics, if shared in the right way with these partners, actually improve performance for everyone. In fact, this ended up becoming so popular that they built a whole new product out of it. It's called Restaurant Manager, and it's out in restaurants now. it actually shows them hour by hour what's going on, but also gives them advice on how to change these things. So things like stay online during these particular hours, and you can do better. So now that we've seen these 3 examples, they're actually a great example of what happens when you bring technical as well as less technical users together on the same platform, allow them to play around with the data, explore the insights that are there, and then actually share them with our end users, our restaurant partners, our driver partners, etc. Along the way, we actually discovered something pretty serendipitously. So when the team started, we were a pretty small team, and as we added these people onto our platform, we were struggling to support them. But because we had technical users also on the platform and we'd already made their lives simpler, we now had more time to coach these newer users, to teach them new techniques, to show them how things are done. And that actually built up really powerful communities across our global offices. Today, it's a very thriving community, and teams are teaching each other interesting things and sharing other interesting insights with them. So it's pretty cool. With that, I'll hand it over back to Milene.
Thank you. So now I'll conclude on this talk before we can open it to Q&A. So we hope that by showing you those very precise examples of cases when data science was not just used by data scientists, we also inspired you to democratize data science in your own organizations. But really, what did we learn? The first thing we learned is that it's important to build for the experts, the data scientists, because you want to get the data science right. But then it's also as important to design for the less technical people so that they're able to interpret the results without making mistakes. We also learned that it's great to productionize some of the known methodologies, such as the analysis of experiments, but it's also very important to empower people to look for the unknown. A tool showed us a bunch of examples that probably we could never have thought about if we were not having open data science methodologies for everyone in the company. And finally, we learned about the importance of communities, and communities that have both data scientists and non-data scientists in them. Because if you silo those 2 sets of users, you won't see a lot of knowledge sharing happening. But by having everyone in the same community using the same tools, we see a lot of collaboration happening in the company. I also want to show you this tweet. So I came across it while I was preparing for this conference. It's from Hilary Mason. She's a famous data scientist. And she asked this question: if you were to learn one programming language, which one would it be? And this person answers R, because learning a new language should give me new powers, not just syntax and libraries. And as product managers of data products at Uber, this is really how we feel. We're giving people new powers, not just a way to, for instance, query some cryptic database through the command line. We really want to empower people to do more with data. But I also want to address this assembly with a word of caution, because with great power comes great responsibility. And as data people here, whether we're product managers, data scientists, engineers, we have a responsibility to make sure that the data is used properly, even when used by less technical people. And so we have to make sure that people using our data, people using our tools, are able to answer questions such as, am I even allowed to use this data? Or am I introducing bias when I select the data, for instance? Or what is all the impact that I can have if I use this data? And finally, am I just being scientifically rigorous, like we all should be? And so to help people answer these questions, it's very important to talk about training and documentation and have that in place in your organization. We mentioned that in both our examples. This is another example of training and documentation. It's a tool at Uber called the Data Book. It's kind of the go-to place for everything data in the company. So people can go there and find definitions of tables, of metrics, how to use the main tools around data at Uber. And finally, for the people who have followed this presentation entirely, you might have noticed that in my initial definition, I talked not just about statistics, data analysis, but also about machine learning. And we didn't really cover this. And to be honest, we don't really feel that today machine learning is really being democratized at Uber. It's still something that mostly data scientists and machine learning engineers do. So if that's not the case in your organization, I would love to hear more about how you achieve that. But in general, we're pretty excited about seeing that happening in the future because we believe that that's the path we're headed towards. So that's all we have, and we're going to be able to take some questions.
Thank you very much. They will be showing up momentarily. It's a very well-timed question, actually. The one it talks about, I guess I can just say it out loud until it comes up on the screen. What would you call machine learning if you say data analysis is a Swiss Army knife? From Data Girl, by the way, for those of you who've been around. Data Boy's sister.
That's a good question. I didn't think of this one. Probably something very complex that works really well that people don't understand how it works. So I'll need to think of such a tool.
From Anonymous, how do you protect non-data science roles from misinterpreting the data?
So maybe I can take that one. I think like Milene mentioned, we try to build in some guardrails into what we're doing, right? So with the experimentation analysis, for example, there are guardrails built into the process. So it's a complex technique that we are trying to showcase. For the data science workbench, which is definitely a much more open-ended tool, while those guardrails are not there at the moment, we specifically did not want to constrain people, right? So we here rely on some of the more technical people to kind of offer their judgment and indicate that certain processes are incorrect or are not ideal.
Ricardo is asking if the Uber stats engine is open sourced.
So that's a great question. It's not today, but that's something we're thinking about. So I have 19 likes to show my data scientists and convince them to work on this.
Nice. Another one from this anonymous person. How do you assure that parallel experiments don't influence each other?
So we don't really have this problem at Uber because we have such a large population that assuming perfect randomization, they shouldn't influence each other. I'm still happy to talk about some of the more advanced techniques that we have in some extreme scenario. I can talk about this afterwards.
And Chaba is asking a question related to that arrow graph we saw. What is the ratio of users, Reliant Rebecca, Monitoring Matt, Analysts Anna, and Inventor Ivan?
So Uber is a pretty operations-heavy company. We're in every city around the world. Most of these cities have a lot of the Reliant Rebeccas and Monitoring Matts, so they definitely form sort of the bulk of people in those personas. Inventor Ivans, they're more of the engineers and data scientists. I think there are definitely fewer, and which is why we're building all of these cool tools so that we don't have to burden them with even more work.
And Tamash asks, how do you ensure the lack of bias in an automated way?
So I'm not sure this is for experimentation bias or just bias in general. If it's bias in general, it's true that it's really hard. So we try to really always show like full descriptions of the data set, always make sure that people understand that, for instance, if one data set is specific to one category of users, they know that this is relevant only to those users. But it's definitely a hard question.
At this scale, the organization can also learn a lot from past experiences and analysis. How do you make sure that this meta-knowledge is also democratized/extracted?
So that's a very on-time question. So this is something we spend a lot of energy thinking about and that we're building into our roadmaps. So right now it's true that we haven't done a great job doing that. So because we're a very fast-paced company, we tend to always look at the future and not really look behind us to see what was already done. But we're trying to build more of this metadata around experimentation.
All right. Istvan is wondering, how do you define which statistical model to use? Is it always the same for all experience?
So it's not. This is explained more in detail in the article that I talked about. So it's on their engineering blog. It depends mostly on the data, if it's skewed, if it has a lot of variance or not. So we take all that into account to decide which tests to run for each experiment.
And we have time for one or two more. Anonymous is wondering, why did you decide to build your own data science platform instead of buying any similar and already existing solution from the market?
So that's a great question. There are a couple of reasons here. One of them is, back when we started, there weren't really as many data science platforms available out there. So I know that Cloudera had one, Databricks had one, but they they kind of fell short for a few different reasons. So if you go back to that slide, or if you remember that slide where we laid out a few of our requirements, one of the more important ones was also cost, right? We expected that for this platform, there are going to be a very large number of casual users, which meant that licensing would be a concern. The other challenge that we also had was we wanted it to integrate very tightly with our other internal tools and solutions. So if it was an external platform, that may not necessarily always happen because we don't control the destiny there. They have their own roadmaps. And so I think that was, those were like the two major reasons for going the way we did.
Cool. And I think we have time for one last question. How could pre-experiment bias occur at all if randomization is done right?
Yes, so if really in a perfect world, it should never happen. Sometimes it's just bad luck. We've seen that happen a few times. Most of the times, though, it's based on the experiment design. So based on when the events are logged for an experiment, it might actually bias your experiment before it even starts. And again, like that's something I'm happy to talk more in details with people who are interested.
Absolutely. Well, thank you very much. And let's give them all a warm round of applause.
Thank you.
Thank you.